We've seen that lists provide us a really useful and powerful data structure that we're able to build on and manipulate and to store data in. And there are actually lots of other data structures in Python that you can use for other purposes that will add more abilities of what we can do with data. One of those is a dictionary. A dictionary has keys and values that are paired. For example, the social security number of a person to their student record, where the social security number could be the key and the student record would be the value that we look up, or the bank account number being the key and the bank account balance being the value. The keys should be unique, meaning two people should not have, or two bank accounts at least, should not have the same bank account number. Two people should not have the same social security number, and so on. This allows us to look up a value if we know its key. And typically the goal is for the keys to be small and simple to remember or to record somewhere so that we can get to a value that might be more complex. Our examples here will all use pretty simple stuff, but understand that in reality, our values could be as complex as an entire student transcript. We could look up something that stored all of the grades, all of the current enrollment, all of the past enrollment, whatever, from your student ID number or something like that. That's the sort of thing that a dictionary would allow us to do. And so this is similar to how a real dictionary lets you look up using the word as the key. You can look up its definition, and often that definition is much longer than the key, the word here. So that suits our example perfectly. So what do? We associate keys with values to build a dictionary and use those keys to look up the values. Here, for example, we have course numbers mapped to their longer course names. So the key is the course number, and if I can't remember the whole course name, that's okay. All I have to remember is the course number. Now that does mean it's difficult to go the other direction. You can't easily look up the key just by knowing the value. If you know the name of the class's algorithms and you forget that its number is 310, that will be hard to handle using a dictionary. There may be other data structures that you'll see later, for example, in the data structures course, that would allow you to look up in either direction, but a dictionary is meant to look up one way. You look up the word and you get the definition, or you look up the course number and you get the course name. So this line here that says courses equals and then has these curly braces, it defines an entire dictionary right there. It's a dictionary with 3 keys. The keys are 128, 256, and 310. You can tell that they're mapped with particular values because they have the colon between the key and the value. You'll notice also that the keys are integers and the values are strings. They can be of any type you want. And then you'll also notice that the separation between any key value pair and the next key value pair is a comma, similar to our lists. So if you consider the key and value to be one whole item, you can't have just a key with no value, and you can't have just a value with no key. So this pair is one item. Then we use a comma between items, just like we did when creating lists. So now that we have a dictionary that has a few values in it and a few keys in it, we can then use it for lookups. So here we say we would like courses number 310, and then it will give you algorithms as its return value on that line. If I printed it, it would print out algorithms. Now, this looks pretty similar to indexing in a list, and that's intentional. Python tries to make the functionality between different data structures and different structures in the language to look pretty similar. The difference with a dictionary is that because I looked up 310, that does not imply that there is necessarily an entry for 309 and 308 and 307 and all the way down to 0. So I can't assume that every index will exist. And in fact, for a dictionary, the index, as I mentioned, doesn't have to be a number. It can be any data type. So whatever my keys were defined to be, it will look those up. If I try to look up something that is not a defined key in my dictionary, I will get an error. So if I asked for courses 0 here, I would get an error. And if I asked for courses with, quote, cat, a string here, I would get an error because that key does not exist in my dictionary. So here's another dictionary that goes from strings to strings. So the keys are strings, the names of months, and the values are also strings, the names of stones. These are birthstones people often associate with particular months in the year. You'll notice I did not complete this whole dictionary, and that's actually okay because I can add items to the dictionary later, and we'll see how. So here I can look up birthstones January, and it will give me back garnet. But right now, if I tried to ask for birthstones December, I would get an error. So here's one more example where we have a dictionary from strings to integers. And again, we can do our lookups with those square brackets, just like we do indexing in a list, but our thing that we put in there is not exactly an index. It's a key, and it needs to be one of the keys from the dictionary that exists right now. So here we've got a dictionary that matches names to ages. And this one gives us 8 because that's the value matched with the key mittens in our dictionary there. So what if we wanted more than what we started out with in the dictionary? In fact, what if we even wanted to start with an empty dictionary and then let our user add items to it? We could do either of those. We can start with a dictionary that has some things and add things to it later, or we can start with a dictionary that's empty and add items to it one by one. So if we met Snowball, who has an age of 1, then we could add them to our dictionary. We do it similar to how we look stuff up, except we say it equals something. And we were able to do this in lists for indexes that already existed. But for dictionaries, it's different. I can do it for indexes or for keys that already exist to change their value. For example, if Carol had a birthday and we wanted to increase Carol's age to 31, then I could say ages Carol equals 31. But if I meet someone new and I want to add them to my ages database, my ages dictionary, then I say ages, that new name, like Snowball, equals some number, whatever their age is, 1. That's equivalent to if I had that item inside the curly braces when I first created the dictionary. So it's quite common to start out your dictionary with only a few values or completely empty, and then be adding items to it in this way. It's also quite common to need to change the value that's associated with a particular key by doing what looks like a lookup and then saying equals some new value there. So you can both add to the dictionary or change the values at existing keys with the exact same statement. You also can do lots of other things with dictionaries, much like you can do with lists. You can check for containment using the in keyword, and you can do lots of other things that you can check out as you start to work with dictionaries. So here's the example of changing something. If Sky got a year older, then we can set ages Sky equal to 4, and that will change the value as if we had included 4 in our original version of the dictionary. This bottom thing is just an example of what would get us the same dictionary as we have at the end of this line. We don't have to rewrite the dictionary in this way. It's just to demonstrate that's what the dictionary's value would look like right now. If I printed it out, these are the keys and values as pairs that it would have in it. Here we've added another entry to the dictionary. We've added Pumpkin, who's age 1, and that's okay to have 2 entries that both have the same value. Snowball is 1 and Pumpkin is 1, and that makes logical sense. We can know multiple people who are the same age, but also I want to point out that that is valid for a dictionary, that you can have 2 of the same value that 2 different keys map to that same value. What you cannot have is 2 of the same key. If I tried to make another entry for a different Kevin that I met, then I would actually be replacing the Kevin that's already in there. I need to make sure that my keys are unique. So we could add last initials to the new Kevin we meet. So that could be Kevin B, and our other Kevin is just Kevin, or that sort of thing. This makes a point about design, that it's important to try to come up with keys and values that will be somewhat unique come up with keys that will be somewhat unique in the beginning. That way we don't end up in awkward situations where one of them is just Kevin and the other one is Kevin B or something like that. So it may have been smart for us to give first name, last name in our original creation of the dictionary to make sure that when we meet new people who have the same first name, so long as they don't have the same last name, we're safe. How do we handle people who have the same first and last name? That's another question. Names are not always the greatest as keys because they can be duplicated. So we also can get a sequence of all the keys, a collection of all of the keys from our dictionary. Here, for instance, we're using our ages dictionary still, and we can ask it for all the keys. This is a sequence that's sort of like a list. It's actually a little more like a range because we can't insert into it or change it as we use it, but we can iterate over it, meaning we can loop through it. The same is true for the values. We can request from the dictionary all of the values. We have to be careful about doing this with the values because often the values don't make sense if they're not paired with their keys. For instance, just having the names here doesn't really tell me any helpful information about just having the ages here, which would be the values, doesn't tell me any useful information about whose age I'm looking at. So I guess if I wanted to know the average age of all of my friends, I could get the values and I could find the average of them. But Often the values don't make any sense unless they're paired with their key. So another thing that we can do is we can loop through all of the keys, and we can use those keys to look up each value. So this is just an example loop, but the idea is that I could go for each key called K in my loop here in ages keys. I could do something like print the key and the value on the same line, or I could update the value for each of those keys. Let's say I know a whole year has passed, so everyone must have gotten a year older. Then I can loop through that ages dictionary in this way, taking each entry and setting it equal to itself plus 1. So here's an example that you could think through and that we might get to spend some time on in class, is to build an interactive phone book. So it can ask a user for a name and a phone number and add them to some dictionary that presumably would start out as being empty and then would get entries added to it. When the user enters an empty string for a name, then your loop stops and you return the dictionary. Don't enter the empty string into the dictionary. So you can add all of the people that you want into that dictionary. You can't add my cat, Jimmy, because he's been misbehaving and climbing on doors. So don't add him to the phone book. But anyone else that you want to, you could add. You could even possibly set it up so that there was a way to then come back later and add other entries to that if you really wanted to challenge with it. But overall, this kind of idea would be a good example of the sort of thing that you would use a dictionary for. Being able to have some sort of unique key, like the names of our friends, hopefully are unique, or we can make them unique in some way, that maps to some value, a phone number. That value does not have to be unique, just like two people might live at the same house, and in the weird world where people still have landline phones for their house, they might have the same phone number, but they have to have unique keys. And so then you can add key and value pairs to the dictionary at later points. You can even update them if you need to, using the key and assigning a new value. And this provides you a new functionality, new information that just, for instance, a list alone couldn't, because there's a relationship displayed between the key and the value, that they match to each other in some way.